Think about building a house for a second. You wouldn't just, grab some wood and start hammering away, right? Of course not. You'd need a blueprint, a super detailed plan showing where every single wall, window, and wire is supposed to go. Well, it turns out the world of software works the exact same way. Before anyone writes a single line of code, having a solid plan is absolutely the most critical part of the whole thing.
Oh yeah, we've all been there. You're tapping a button and nothing happens. Or a feature you desperately need is just not there. Or the whole thing is just painfully slow and clunky. And in that moment of frustration, you probably blame the app, right? But the real problem, the root of the issue, almost always started long, long before the coding even began.
And this quote right here, it really hits the nail on the head. That frustrating app that drove you crazy, well, it's just a symptom of a much, much deeper challenge. You see, often the hardest part of building great software isn't the technical wizardry. It's getting a crystal clear understanding of what the software is supposed to do in the first place. So let's get this straight. When a big, expensive software project totally fails, it's rarely because the coders were bad at their jobs. Nope. It's almost always because they were working from a bad blueprint. The team was building something based on a plan that was flawed, incomplete, or just plain misunderstood. They were basically building a disaster from day one, and they might not have even known it.
So, to prevent that kind of disaster, there's a whole professional discipline called requirements engineering. This is the structured, formal process for creating that perfect blueprint. Its entire job is to build a rock-solid bridge from a vague idea in someone's head, that wouldn't it be cool if moment, to a detailed, actionable plan that developers can actually use to build something amazing.
The actual thing you get at the end of this process is a document. It's often called the SRS, or System Requirements Specification. The best way to think of this is as the project's constitution, or its Bible. It is the single source of truth that the client, the managers, and the developers all agree on. This is the master plan.
But hold on, before we even start drawing that blueprint, there's a huge first step. We have to stop and ask a really fundamental question. Should we even build this thing at all? This is called a feasibility study, and it really boils down to 3 key checks.
First up is technical feasibility. This is the can we actually pull this off check. It's the real nuts and bolts stuff. Do we have the right technology? Do our developers have the specific skills needed for this job? It's a hardcore reality check on our technical capabilities.
Next, there's operational feasibility. And this one is all about the people. I mean, think about it. You can build the most technically brilliant software in the world, but if it doesn't solve a real problem for anyone, or if the people it's designed for just won't use it, then it's a failure. It's a total waste. Will this new system actually fit into the way people already work?
And finally, the all-important bottom line, economic feasibility. Is this project a smart investment? You have to weigh the total cost, development, new hardware, training, all of it, against the financial benefits you expect to get. If that return on investment just isn't there, the project is a no-go. It's as simple as that. Okay, so let's imagine our project passed the feasibility check with flying colors. Great. Now we can finally start writing the blueprint. And this blueprint is basically made of 2 fundamentally different kinds of requirements. Let's break them down.
Okay, this difference is crucial. You've got functional requirements, which describe what the software does. For instance, the system must have a button to upload a photo. It's a feature. Then you have non-functional requirements, which describe how well the software performs. For example, the photo upload must complete in under 2 seconds. It's a quality. Think of a car. The engine, wheels, and steering are functional. The top speed, safety rating, and fuel efficiency, those are non-functional. You absolutely need both to have a good product.
And what's wild is just how broad this non-functional category is. It's not just about speed. It covers product qualities like reliability. Will the app crash all the time? It also includes organizational rules like company-wide coding standards that developers have to follow. And it even covers external things like legal requirements for data privacy that the software absolutely must comply with.
So we know what goes into the blueprint, but how do we actually create it? How do we get from a bunch of vague ideas and wishful thinking to that highly detailed official SRS document? Well, it's not chaos. It follows a pretty clear 3-step process. First is elicitation, which is really just a fancy word for gathering information. You're doing interviews, running workshops, observing users, just collecting all the raw needs and ideas. Next is analysis. This is where you take that messy pile of information, organize it, and make sure it all makes sense and that there aren't any contradictions. And finally, specification. This is where you write it all down formally in that SRS document we've been talking about. The blueprint is now ready.
Now, at this point, you might be thinking, man, this sounds like a lot of meetings and paperwork before you get to the real work of coding. And you're not wrong. But this upfront investment, this planning phase, is what separates the successful projects from the ones that are doomed to fail. Let's look at the payoff.
And the benefits are huge. When you have a great blueprint, you slash costs because you find errors early when they're cheap to fix. You dramatically improve the software's quality because everyone agrees on what good actually looks like. Communication becomes crystal clear, the project stays on track, and the final product is so much more likely to be something people actually want and love to use. You completely avoid building that buggy, confusing app we talked about at the beginning. So I'll leave you with this thought. The next time you're using an app and you come across a feature that is just perfect, it's fast, it's intuitive, it just works, take a second. Yeah, absolutely thank the coder who brought it to life. But also, give a little nod to the planner, the requirements engineer who first defined in painstaking detail exactly what needed to be built. They are the true unsung heroes of the digital world.